So this is number 39 from 7.5, like this. 5 to 136. Because that's going to be, 156, thank you, right. I have a side note. Could you do this one with it inverted? Could you do 156 over 5? There would be a way to do that, but it's a little bit kind of more accustomed to this way. And then it says he uses 3 gallons of gasoline in the car, and he wants to know how much more gasoline he will need to drive 300 miles. So he has 3 gallons in the tank and needs to know how much more he needs. But how far does he have to go? 300, right there. So yes, if we weren't going to write it out first, which we shouldn't, I was kind of skipping ahead there. X is what?
X equals the amount of gas.
Amount more gas to put in, right? Correct?
Yeah.
And how much was in there to begin with? Put in. 3 is already in there. So the ratio still needs to stay the same. So when you now have a fraction equaling a fraction, we don't have to combine anything. What can you do? Cross multiply. So you know that 156 times 3 plus x is equal to what? 5 times 300. So it's going to be 3 plus x is equal to 1500 minus what? 1500 divided by what? Sorry. Thank you, Alyssa. So would you need your calculator to really get a decimal answer to this? Yeah, you'd need that. Minus 3 equals what? 9 point what? 6? And it says to the nearest what? 10th? 9.6 gallons, right? Okay.
I got that.
Good.
That's not with the minus 3 though.
Oh, that's not with the minus 3?
Right.
Okay, kids. Sorry, I wrote it up there. I thought that's what.
I think it's 6.6.
Okay.
And then you have to subtract the 3 to get 3.6.
Hold on a sec. So when you do this right here, this should be around 9 point something.
Yeah.
This should be around 9 point something. So this right here. So this right here is going to be probably 6.6. Is that correct? Yeah. Okay. Good. So the answer would be 6.6 gallons. I think it said to the nearest 10th.
Sorry, 6.
What was the decimals? What did it give you? 6. I understand that, but what does it terminates exactly at 6.6? 6.615. Thank you. So if it asked you to the nearest 10th, you would round it to 6.6. Okay? This is important. Remember that rounding can be done 2 different ways. There's on the AP test, they actually accept both. So every now and then you'll do work. On the AP test, you always have to go to 3 decimals, but they actually accept 2 different answers sometimes. You could, for example, have 9.63856. There's actually 2 ways to round that. If you had to go to 3 decimal places, can you give me one? What's one way you could round to 3 decimal places? 38, so 9.639, right? Because you look right here and you say, oh, the 5 makes that go up to a 9. Another way to round that is just to truncate and say the answer is 9.638 and just cut it off. That's another method for rounding. So actually on the AP exam, and this doesn't really affect this class, of course, but on AP exam, they actually accept both of those as the potential answer. But over here, is there only one correct answer? Yeah, because it's not close enough to go up. It's not a 5 or above. So we have a fraction equaling a fraction, so what should we do? So we have e lowercase r is equal to lowercase e times uppercase r plus r. But what are we isolating? We're trying to isolate the r. So our goal should be to get that thing all on one side. So what do we have to do at this point? One word. No dividing yet. Distribute. ER is equal to ER plus ER. So now what do we subtract from both sides? Lowercase e, lowercase. To get the r's on one side, the lowercase r's. So what do we now have? Capital A minus ER equals ER. This is really hard to say. Sounds like I'm Eeyore here. What do I do now? One word. No dividing. What do I do now? Yes, you factor. You take these and you turn it into R times what? E minus E equals ER. So what does R equal? ER over E minus E. This is actually this rates as one of the most annoying to say out loud algebra problems I have ever done. This rates. It's up there somewhere. Like literally.
Why would they do that?
Because they're doing it on purpose because they want you to pay very close attention to the variables. They want you to pay very close attention to what you're simplifying. But it's really annoying to say this out loud. I'm going on record right now, and I might. The simple way to remember if something is direct variation is if the relationship can be represented by y equals kx. But the super simple way to remember this That is a line through the what? The what? And the x-axis, but where does it cross both of them? What? The origin. K is any constant. K could be 6, 7, 12, pi, -2. But no matter how you write that line, y equals 2x, y equals 3x, y equals -x, y equals 2/3 x. The line always goes through the origin. So if you're looking at a line that goes through the origin, you could say that the two variables x and y vary directly. What you're going to spend some time doing is finding the k value. Finding the k value. Finding the k value. So we can make one of these up pretty easily. Give me any x value you want, Katie. Kelly, give me any y value you want. 3. If I told you that x and y vary directly, you know that y is equal to k times x. But you just told me when x is equal to 2, y is equal to what? So that means that 3 is equal to k times 2. Can you solve for k? K is equal to 3/2. So what do you now know the relationship is? Y is equal to 3/2 x. You just solved for your first constant living in front of x in a direct variation question. These are certain types of word problems that they follow. Right there. So we plug in x is equal to what? I think they said 400, right? See 400 right there? 400. So we plug x is equal to 400, so y is equal to 4/75 times 400. Is that something you can simplify? Yeah. Yeah, that's going to be 1600 over 75. Can you simplify that in your head? What's the biggest common factor you can think of 1675? 25. How many times does 25 go into 75? 3. How many times does 25 go into 1600?
64.
So it's going to be how many times?
64.
Correct. Yeah, that's really good. Good job. Is it, yeah, I mean, the way you think about that is, how many times does 25 go into 100? 4. How many hundreds? 16. What's 16 times 4? 64. Very good. So can we cancel the 25s? Yeah, I would generally give you a calculator. So what's the answer here? If you apply 400 newtons of force, how far is the spring going to stretch? 64/3 meters. What is that around? That's around. That's not around. That's exactly what. That's 21 and how much? 21 1/3 meters, right? Or we can do 0.3. What's a little better way? 0.33 repeating, right? Does that make logical sense? Should it be longer or shorter? Oh, if we're applying more force, should it stretch further? Yeah, it should. Absolutely. So the point is you're going to solve for k and then plug something in. Now, this section goes over different types of relationships. They get a little nastier, like two things put together. The main one you need to focus on is direct variation. That's the one you're really going to see most frequently. And one that's very similar, which is inversely proportional. And only one thing changes when it's inversely proportional. And but the big things right here are k over x and k times x right here. Those are the two big things. The other kinds of relationships that they describe, the only thing they change is the power of x. That's what we're going to talk about later. But the big thing is directly proportional is kx. Inversely proportional is k over x. Yes, Rachel, when you see direct, you're going to write y is equal to kx. But what's the one thing you're going to have to add in? X what? X to the second. This is directly as the square. Those are the two big things right there. It says if a skydiver falls 64 feet in 2 seconds, how far will she fall in 8 seconds? So what's our initial point? What do they give us? 64 feet is done in 2 seconds. Now let's label our variables. Which one do you think is going to be time and which one is distance? So x is time. We like x being time because time is usually what's in the equation. And what are we getting out? Distance. We're getting distance. So we need to solve for k first. So what are we going to plug in? What's on the left? 64 k 2 squared, right? So k is going to be 64 divided by, which is what? 16. Thank you. That's right. You're actually, just kidding. Wow, just stick with it. You're good. So what is our relationship? Have we solved for k? Yeah, y is equal to 16x squared, right? So now what does it ask? It asks, how far will she fall in 8 seconds? What do you plug in?
16.
X is equal to
Oh,
8, right?
yes.
X is equal to 8. So y is equal to 16 times 8 squared. So y is equal to 16 times 64. Is that pretty big?
How'd you get 8?
Because it told us right here. It says, how far will she fall in 8 seconds? Just because they told us that. So is that a bigger number? Yeah, that's pretty big, right? Does that kind of make sense? You speed up. Now there's one, they say, if we disregard resistance, is that kind of actually important if you're going to do this for a real life problem? Yeah, because here's the thing. If you drop from an airplane from 30 miles up, which is what Felix Baumgartner recently did, do you reach like an infinite speed as you fall? No, you don't. You hit terminal velocity, which varies depending on air pressure. The higher you go, listen, the higher you go, the higher terminal velocity is. He did something which was phenomenal. He broke 3 world records in his fall. One of them was he broke the sound barrier while in free fall. 700 miles an hour. He went faster than 700 miles per hour in free fall. The reason that's so hard to hit is because of this. If you're at atmosphere, if you're only like a mile or 2 up when you do regular skydiving, terminal velocity is like 127 miles an hour. So in order to be able to get to 700 miles per hour, do you know how high you have to go?
The stratosphere.
30. You have to go low. 30. He's 30 miles up, right? He also broke the record for longest free fall in terms of distance. He did not break the time in free fall, though. He did not break the time in free fall, though. Do you know why? Because he went so fast. He went 800 and something miles an hour at his fastest speed. Well, here's the thing. So the big question you just asked is why. Anybody? Yeah, it's good physics problem, but why? Why do people do? What? Did you know up until a couple hundred years ago, humans never really climbed mountains?
Probably.
For the same reasons. We're like, why? What's the famous quote that's actually misquoted for Edward Mallory, the guy who hiked Everest? They asked him, like, why'd you do it? You know, his answer was? Because it's there. Similar. Because it's there.